Welcome to
Nay.
Do it.
Channel Everyone. Okay, deep breath everyone. JJ Jiyoung, thank you for being here. So today we are diving into something that feels pivotal. The paper is called OpenSeeker, and the core problem it tackles is something I think our viewers feel intuitively. When we see these amazing AI agents that can search the web and answer complex questions, it always feels like magic happening behind a closed door, right?
That's an excellent starting point, Isabel. You've put your finger on the exact issue. The magic of a high-performance search agent relies on two things: the model architecture, which many researchers can replicate, and the high-quality training data to teach it how to search, which has been a closely guarded secret. It's like giving someone a powerful car but no map or driving lessons.
Exactly, and this data scarcity isn't just an inconvenience, it fundamentally blocks innovation. If only a few big companies control the training recipes, they set the pace and the direction. The rest of the research community is left trying to reverse engineer from the outside, which is slow and inefficient. OpenSeeker aims to break that logjam by open sourcing everything: the model asterisk and the data, completely.
So democratizing the tools. I love that. But JJ, you mentioned the data is the secret sauce. If it's so hard to get, how did the OpenSeeker team create it from scratch?
This is where the technical innovations are so clever. They didn't just scrape the web and hope for the best. They engineered the data. The first method is called fact-grounded, scalable, controllable QA synthesis. Now that's a mouthful. Let me break it down.
Think of it like building a training gym for the AI. Instead of random exercises, you design a perfect obstacle course. They reverse engineer the structure of the web, how pages link to each other. Then, they create complex, multi-hop questions where the answer requires clicking through several links, like a detective following clues. They can control the difficulty and the topics covered.
And to make sure the AI learns the asterisk process of searching, not just memorizing facts, they use something called entity obfuscation. They might replace a specific name like Marie Curie with a placeholder like Scientist A. So the agent has to search for the context to figure out who Scientist A is. It forces genuine reasoning.
Okay, so you build this perfect, complex training gym. But then you need to record the perfect way to solve each puzzle, right? The teacher's edition answer key. How do you get that?
That's the second big innovation: denoised trajectory synthesis. When you use a large language model to generate those step-by-step solutions, it can get messy. It might hallucinate steps or include irrelevant actions. So OpenSeeker uses a retrospective summarization mechanism. It's like having the teacher work through the problem, then go back, clean up their notes, and write a pristine, optimal solution path. This denoised data is what the smaller agent model then learns from.
So quality over quantity. They're not using billions of messy data points. They're carefully crafting excellent examples.
Precisely. And the results are staggering. They trained their model, OpenSeeker, on only 11.7 thousand of these synthesized examples. A single training run. Yet it achieves state-of-the-art performance on major search benchmarks.
The comparisons are the most telling part. It significantly outperforms the best previous fully open-source agent, and more impressively, it even surpasses some industrial models from big tech companies on certain benchmarks. These are models that were trained with vastly more resources, continual pre-training, and reinforcement learning. OpenSeeker did this with simple supervised fine-tuning on their high-quality synthetic data.
That is a powerful statement. It validates the idea that brilliant data design can be more important than just brute compute force or keeping secrets.
It really does. By open sourcing this entire pipeline, the data generation code, the final dataset, and the model weights, they are not just releasing a tool. They are inviting the entire global research community into the workshop. They are fostering a transparent, collaborative ecosystem where everyone can build, inspect, and improve upon these frontier capabilities.
And that is ultimately how we ensure the future of this technology is shaped by many perspectives, not just a few. It allows for more scrutiny, more innovation from unexpected places, and hopefully, more responsible development. The technical achievement is fantastic, but the philosophy behind it might be even more important.
I completely agree. It turns a closed door into an open invitation. Thank you both so much for climbing this ladder with me today and unpacking such a dense and exciting paper.
Thank you, Isabel. Always a pleasure.
Thanks for having us.
And thank you to everyone watching. We'll see you in the next one.